So we're back working on this 2009 Chevy Silverado hybrid, and the customer elected to have me do the repairs on this thing, or attempt the repairs. So I'm going to reach up behind this inner fender skirt. You can put a little piece of 2x2 in here, and you can flex the skirt out enough to reach up there and pop the connector off of the frame. I need two hands to do it. And we're going to try and fish the wiring harness down so that we can plug in the new sensor and see if the code clears. So there's the connector at the top of the frame. You have to push this little push pin out of the frame rail on the top, was quite a challenge. But if you use one of these clip tools, that works pretty good. And there's another, the harness runs along the back of the frame here and then across above the spare tire. So check carefully at the connector back to see if there's any corroded terminals. I don't see anything here. So we're going to wait for the new speed sensor and simply plug it in. Plug it in and clear the code and see what happens. Well, I've got the speed sensor plugged in. You see the ABS light is still on, traction control message is still there. Let's turn the headlights off. But the airbag warning light is off, so let's scan it and see what codes we've got. So we're going to go into the ABS, codes menu, clear codes. We'll give that a chance to reset if anything. We'll go into the airbag, display codes. Shouldn't be any current codes, but there should be a history code for the left crash sensor. Yeah, that's front end sensor 1. 1 is on the left side. So we're going to clear that code. We did change both sensors because the one good one was starting to split, and I put OEM sensors in it. So let's go back into the ABS now and see what codes we have. Current. Oh no, that's not good. So we must have a wiring problem between the ABS hydraulic unit. Now we're going to have to check some wiring. So sometimes the codes don't clear on these ABS systems until you drive it over a certain speed. And I'm wondering if that's the case here. So I'm going to check for a speed signal from first the left front. Yeah, and I'll go to the right front. Now, left rear. Now to do the right rear, I'm going to have to put a piece of metal in front of the sensor. Let's grab a screwdriver, and I'm going to try and simulate a signal. No, we got no signal. Okay, so we're going to pull up a wiring schematic for this and check continuity of the wires. So here is the wiring diagram, which apparently is unique with HP2, which is the hybrid. So left front, left rear, right rear. So like I said, it outputs at 12 volts on that circuit, but if it sees a problem with the wiring or a problem with the sensor, it shuts down to 12 volts. So pin 2 and 3 at the EBCM to the connector. So we're going to take apart the connector at the EBCM and identify the wires, check continuity. So there's a little plastic shield underneath this ABS unit. It's considerably bigger than the non-hybrid version, but the wiring harness
has been rubbing on the bottom of that shield, and it's worn through the loom, it's worn through the tape. I wonder if there's a compromised wire right there. So I peeled the insulation off of that. The wires look pristine. Got to find out what color these wires are that we're concerned about. We're going to take the connector apart up here. So according to the schematic, the twisted pair should be gray, black, and brown. Well, I'm looking at the wires here. And I see, oh, there it is. Gray, black, and brown right there. And that's supposed to go to pins 2 and 3. I'll have to get a magnifying glass to see if there's any numbers on these pins, or get a pin out. I don't want to take this back cover off unless I have to. So there's the connector view looking into the face. It's pins 2 and 3 according to the schematic. 2 and 3. So I'm using 2 probing pins, 24 thousandths of an inch. Don't use anything fatter than that or you'll spread the terminals inside there. So now we're going to check continuity between here and the back, and I'm going to put a couple of terminals on the harness at the back and jump them together to see if there's continuity now. So I got my ohm meter connected between pins 2 and 3, and at the back of the truck on this connector I've got 2 terminals in there, and I've got them shorted together, so I should have a loop. And according to the ohm meter, turn off this light, I've got greater than 40 ohms resistance. Let's see. Let's try 400K. So we have a corroded wire someplace. 265,000 ohms. Question is where? That wiring harness runs up over top of the frame. On the outside of the frame. So anywhere it might rub, there's a spot right above the parking brake bracket. Well, what I'm going to do is graph the resistance and try moving the harness to see if I can see a change in the voltage, or the resistance voltage. Okay, I'm reading 160K, so I'm going to try manipulating the harness. Of course, if the wire is completely corroded through by now, it's not going to change. Let's see if I can go up above the tank here. Above the spare tire, maybe. Well, I'm going to see if I can find a spot in the middle of the harness to qualify it. There's no connectors in between, according to this. A and B is at the wheel speed sensor itself, and that's where I'm testing it. Well, I'm going to look around. So right at the actual connector, I'm manipulating the wires at the connector, and you can see the resistance is changing here. So something's wrong right in here. Let's untape it. Nobody's been here. Nobody's touched this. Is it right at the terminal? No, it's not right at the terminal, as far as I can tell. Oh, my jumper fell off. Well, I'm going to untape this harness. I don't really want to drop the spare tire unless I have to. definitely in this spot. Now, how would that get compromised on top of the frame? This is why I love a graphing ohm meter. I'm not even loading the circuit with an ohm meter, but it should have been 0. I'm going to show you what I found. The green death. That's like 10 inches, no, about 8 inches away from the connector. Well, that's the 15% I said yesterday. So I use uninsulated butt splices and soldered and heat shrunk. I'm going to twist this back up again and tape it back up. Double check it with continuity. So I've got 0.3 ohms resistance. There's the compromised piece of wire. There had to be a pinhole in the insulation and the salt got in there and attacked it. So let's tape this up, put this back together, blow the sand out of that connector, put some dielectric grease on it, and hopefully that's going to clear the other code that was potentially going to require replacement of the hydraulic unit. Well, key on. That's a good sign. There's no ABS light. Display codes, current. Okay, we still got these regenerative axle pressure sensors short to battery. Let's see if we can clear those now. ABS light was off. Okay. Let's look at data. Specifically the rear speed sensors now. Left rear, right rear. I'm going to turn both rear wheels. Good, we got speed signals on both sides. Beautiful. Let's check codes again, see if those regenerative codes came back. Yeah, they did. But the funny thing is, there's no ABS light on. I'm going to take it for a road test and see if they'll clear now. Interestingly, we got the only message on now says service break soon. ABS light is off, traction control, StabiliTrak light, airbag warning light, and check engine light. I did change the 2 oxygen sensors as well. It said something about reinitializing, or let's read that fault code troubleshooting chart again. So the 2 fault codes I have are a C012C failure symptom 01 and a C012C failure symptom 0F. Regenerative axle pressure sensor short to battery, and 0F. Regenerative axle pressure sensor erratic. So I have a 04. Using the scan tool, perform the EBCM module setup, EBCM relearn. Well, I don't know if I can even do that with the scan tool I'm using, this Snap-on Veris Edge. I would think not, because it's probably hybrid only. ABS pump motor on and off. That's it. I'm sure that's not it. I'm going to hook up the Tech 2. So I hunted high and low for the DLC connector for my Tech 2 and I couldn't find it at first, so I decided I'd try my MaxiSys Elite, which I updated last year for nearly $2,000. And there in the special functions is automated bleed, acceleration sensor reset, BCM primary piston position relearn, and EBCM relearn. Let's see if this works. Are you sure to reset? Okay, yes. Clear DC, so you want to electronic and clear code, turn vehicle off for 1 minute before starting, performing test drive. Trouble codes, erase codes, yes, yes. Now we're going to turn the key off for a minute. Not going to make you wait a minute. Alright, that's been a minute. Turn the key on. Well, as you can see, service break soon. Read codes. Regenerative axle pressure sensor erratic. I'm going to try taking it for a test drive. So I've driven it a short distance and the service brake message is still on the dash. In the data stream it shows regenerative braking status active, and I'm sitting here parked with my foot on the brake in drive, and it never changes. I don't know if that's normal to say inactive. Other than that, I don't see anything else in the data stream that is questionable. See, it says active all the time. I think I'm going to try the Tech 2 now. So I'm going to try this EBCM relearn with the Tech 2. I heard it do something. Reset. Now I actually have it in idle stop mode right now. Master cylinder pressure offset learn unsuccessful. I don't have my foot on the brake. Maybe I gotta do it with the key off, just in the run position, not with the engine running, where it's not really running, but when the tach is in 0, it's actually key on, engine off. When the tach is in auto, it's actually idle stop. So let's try this relearn again. Master cylinder pressure offset learn unsuccessful. Primary piston relearn. Acceleration sensor reset. Well, the service literature didn't say anything about foot on the brake or off the brake or exhausting brake, master cylinder pressure or anything like that. But nothing's working here. Let's look at data. We fixed the speed sensor. BCM primary piston position. I wonder what BCM stands for. Normally that's body control module, but it's got to be some other acronym. Accumulator pressure. Master cylinder pressure, negative 100 kilopascals. I want 300 kilopascals. Brake pressure sensor. That doesn't make sense. Why is that jumping all over the place? When I step on the brake, it goes to 400, 500. Release the brake, goes to negative 100. Well, some very erratic data parameters on here. Master cylinder pressure is negative 100 kilopascals. Brake pressure sensor is jumping from negative 100 to 0. And the rear brake pressure sensor is jumping all over the place. 20,000. If I step on the brake, well, I have access to another one of these vehicles, but it's a Tahoe. I would imagine it's the same. I'm going to collect some data on it and see what's going on, because according to the troublemaker chart, the next step is to replace the EHCU. I priced it out today. It's got to come from the States. It is available. It's 25 or 2,700 Canadian. Plus, it's not going to be 5 minutes to change because you got to undo all the hydraulic lines. So I'd rather be kind of sure of this before we do this. We did manage to get all the other lights to go out. I'm going to check the ECM to see if some of the brake sensor codes were turning on the check engine light. So in the EBCM, electronic brake control module, ABS module, it sets a C012C, but in the ECM it sets these codes, C12BA, B9, and BB. They're all basically the same fault. So let's follow the troublemaker chart. Using a scan tool, perform the EBCM module setup, EBCM relearn. Verify the DTCs is not set. If the DT is set, replace the brake pressure modulator valve assembly. If the DTC resets, replace the EBCM. So they want you to change the hydraulic unit first, and if that doesn't fix it, change the electronic brake control module, which is a separate part on the hydraulic unit. I didn't price that. And I'm sure the EBCM has to be programmed to the vehicle. I would think the hydraulic portion of it would be plug and play, so to speak. Oh well, time to do some more research. So back to the snap-on scan tool, you can see the proportion brake pressure in PSI is jumping all over the place. Master cylinder pressure is at negative 14 PSI, which was 100 kPa, negative 100 kPa. That might be normal. I don't know, but this one doesn't make sense. I'm going to step on the brake. So the accumulator pump ran, but this one's jumping all over the place. So I went to take it out of the shop because I was going to give up for today, and the check engine light came on. I just want to see if there are any new codes now other than those regenerative braking codes. Doesn't look like it. So that answers the question. After a couple of cycles, these codes, or one of these codes, will turn on the MIL, which is a pain in the ass because now he's got an MIL on plus a message to service brake soon.